Can we just combine all the space telescopes into a giant interferometer with insane resolution? When will new interstellar objects become mundane? Which rock should China take from Mars to Earth? And Q&A Plus, what's going on with Vera Rubin's data? All in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question popped into your brain, just write it down, I'll gather them up, and I'll answer them here. All right, let's get into the questions.
Montgomery Wood, what resolution would be possible if you combined the dozens of telescopes throughout the solar system into one? So this is this incredible idea that if you separate telescopes by some distance and you align their observations down to the wavelength, right? Like if you think about visible light, it's going at, hundreds of nanometers wavelengths, right? Every second that goes by, countless wavelengths are going past you. And if you, in two locations, you can line up those two wavelengths down to the specific nanometer, then you create a telescope that has the resolution of the separation of those telescopes. So if the telescopes are 10 kilometers apart, and you're able to align their observations, the light that comes into them, down to the specific wavelength, then you get an interferometer. And now you have a telescope that is 10 kilometers across, which is incredible. And this has been tested out. There is a telescope here on Earth called the Chara Array. It's in the US, and I think the telescopes are separated by 300 meters, and it's a visible light telescope. And some of the most detailed observations of the surface of stars have been taken with the Chara Array because they are separated by this enormous distance. They're acting like a telescope that is hundreds of meters across. But the downside with an interferometer, and there's like the first downside, is that you get the resolution. You're able to pick out details on the surface of something, but you don't get the ability to see faint objects because really you're still, if you've got two 1 meter telescopes and they are separated by 300 meters, they're only seeing with the amount of light gathering capacity of those two small telescopes. Yes, if something is incredibly bright, then you can reveal features on it. So you can look at stars, you can look at the sun, but you can't look at faint things. You can't look at galaxies, things like that. You can't look at nebulae because they're very faint and you require very big telescopes to see faint things. So what you're asking is the equivalent of this question, which is like, okay, so we know that there are a bunch of telescopes that are around the solar system. We've got, say, a half-meter telescope on the Mars Reconnaissance Orbiter, which is tens of millions of kilometers away from the Earth. You've got the Hubble Space Telescope. And so if you synchronize the Hubble Space Telescope and the Mars Reconnaissance Orbiter, you would be able to build a telescope that is tens of millions of kilometers across. You would have the resolution of a telescope that was tens of millions of kilometers across. And yeah, maybe you can't look at lots of stuff out in space, but maybe you could look at Betelgeuse and get some answers. Maybe you could look at really bright stars and try to get some answers. And so theoretically, the answer is yes, you could do that, right? You could record all of the light that came into the Hubble Space Telescope, record all the light that came into the Mars Reconnaissance Orbiter, and then you would line up that light perfectly to the point where you get this interferometer forming between the two of them. Practically, it is impossible because you are getting, 500 nanometer wavelengths. You're getting so many photons that are going past. How do you know which is the photon, right? Which is the wavefront that you're going to try to line up? The only way this post process works is with the longest wavelengths. And that's why I say the Event Horizon Telescope, which is this worldwide telescope network on Earth, where you've turned all of planet Earth into a giant telescope. It only works in the radio waves because the wavelengths are very long, right? They can be many centimeters long. And so you can just record all of the data coming into the telescope with an atomic clock, and you can measure as the wavelengths are going past. And then you take all of those hard drives, you take them to some place, and people crunch all of the data in and line up the time codes so that those wavelengths are lined up. And suddenly you're able to use telescopes that are really far apart to be able to image the shadow of a event horizon around a supermassive black hole that is tens of millions of light years away from us. But once you move into the visible spectrum, infrared, all of these, then the only way that you can make this work is if the telescopes are relatively close to each other and they are connected with a fiber optic cable, and you are watching very carefully for anything that is going to change. Like if a truck rolls by, that's going to subtly change the length of the cable, and now your interferometer is busted. So, there have been, like, it's an incredibly powerful technology, and there's some really interesting ideas. You know, people are suggesting quantum telescopes so that you could theoretically just automatically collapse the wavefronts down and pull out the data without having to do this time code thing. And I'm researching this right now. We'll probably have an interview about this soon. But just like in general, unfortunately, it's just practically too difficult to do. But, you know, some of the best ideas that I like are these space-based interferometers, that if you did this on purpose, like you take two telescopes, you take them to space, you set them up so they're firing a laser towards each other, and then they're aligning their distance down to the nanometer so that they're able to be perfectly aligned. They're gathering their data. They are acting like a telescope as big as the separation in between them. This is the kind of work that's being done with the LISA experiment, which is going to be maintaining this space-based interferometer to detect gravitational waves. People suggest you can do this physically on the moon, that you can set up multiple telescopes, separate them by however many meters, hundreds of meters that you want, and you will suddenly create the most powerful, highest resolution, highest sensitivity interferometer, visible light telescope that's ever been built. These are all great ideas, and they should all be done. And, you know, if there's more funding for space and astronomy and for space science and for upcoming missions, I think we would see this. You know, people have been trying to build interferometers and propose space-based interferometers for decades, and they just end up being too expensive, too complicated. Nobody's able to do them. So for now, even though you could create a telescope, like if you put a telescope on either side of Earth's orbit, you would have a telescope that is 300 million kilometers across. That would be amazing. That's a very big telescope compared to the 10-meter telescopes that we have down here on Earth. That would be incredible. And if you put lots of them around the orbit, you could create this big ring around the Earth's orbit, and you could combine all their light, and you could see with a event horizon telescope the size of Earth's orbit. That would be great. But it's just, when you think about all of the gravitational interactions between all the objects in the solar system, moving the telescopes around, you move them a couple of nanometers, they're out of alignment, and they no longer work as an interferometer. 1,000 dots. If we're expecting to discover thousands of interstellar objects every year, at what point do they stop being newsworthy? Pretty quickly, I think. We're not going to discover thousands, but we will discover dozens. 6 to 12, maybe more, interstellar objects will be found every year. So I think we're going to get pretty excited about the first few, and then after a while, we'll stop talking about it unless something really interesting is found. It's the same way with exoplanets. Like, I don't announce every new exoplanet that has been discovered. I talk about some really interesting ones, the ones that are at the edge, but I don't talk about all of them. I don't announce SpaceX Starlink launches. It's just like more satellites going into space. Thing we've seen. I don't report on airplanes flying either, right? Like at a certain point when this becomes commonplace, then we shift from announcing each individual object and obsessing about it into the larger meta understanding of the phenomenon in general, which is what we're doing with exoplanets. We've classified exoplanets. We talk about concepts in astrophysics. We don't report on every single supernova that astronomers have found. We don't report on every gravitational wave. Like, there are gravitational wave events now happening about once a week that LIGO, Virgo, Kagra, they are detecting colliding black holes about every week. We don't talk about it anymore because now the deeper question is, like, what are we seeing from all of the gravitational wave events? What is that telling us about the nature of colliding black holes, about the evolution of black holes? Those are the questions that we shift into, that we will still be reporting on. So there will be this time when an interstellar object will be discovered, and I won't tell you, because it's just not news anymore. And that's just natural. And then we'll move on to other weird things that we find for the first time, because that's news.
It's time to shout out all the new $5 patrons and above. Huscarl, Larry Watson, Marcin, Ernesto Sacristao, Harvey Kelber, Adnan, Derek, Andreas Listy, John Scott, and Jeff Watling. Join the club at patreon.com/universe today.
Matt Hanke if China does Mars sample return before NASA, will they take the Chiava Falls type rock, or will they straight up take the Perseverance samples? Right now, we're talking about this really cool rock that the Perseverance rover studied, which has what appears to be ancient evidence of microbes in the, mixed in with this sedimentary rock. Now, there are other possible abiotic explanations for it, but the researchers working on it have worked through every single possibility and have ruled them all out. So they don't know how they could have formed not with life. Doesn't mean that life formed it, but the researchers haven't figured out a way to get there. And so it is probably the most interesting rock that has ever been found on the surface of Mars. And it would be absolutely incredible to bring that rock back to Earth. So could the upcoming Chinese Mars sample return mission return that rock? Absolutely, right? That they're going to have to pick some target on the surface of Mars, and they're considering various candidates for their scientific utility. And the Chinese version of the Mars sample return mission, the one that's going to be flying in 2028, is planned to be kind of more quick and dirty. It's going to fly to Mars, land on the surface, look around, pick up some interesting rocks, put it in a collection, and then blast off the surface of Mars and bring those rocks home. And then researchers in China and around the world will get their hands on the first samples, fresh samples retrieved from Mars. But you have to land somewhere. Why not land right by that really interesting rock that Perseverance found? Now, China knows where that rock is. NASA has been keeping a very detailed catalog of all of the motions across the surface of Mars. We know exactly where this rock is. Anyone who is able to navigate at the surface of Mars could land at this rock. Now, who knows if it is a very safe landing spot, right? It could be jumbly. There's lots of terrain around there. It's not safe to land on. So you probably have to land close to it and then deploy some kind of rover that could retrieve the sample. That makes your mission more complicated, adds mass to it. They're really trying to dial down the mass and complexity of this mission. So it's just grab and go. But the thing you're mentioning is, could it grab one of the Perseverance samples? Again, those are tagged. They're on the surface of Mars. Now, those are the backups. So Perseverance is carrying samples, its main samples, inside of itself. It has a sample collection component that is carrying inside of it. And then it's also dropping backups of its samples across the surface of Mars. So if something ever happens to Perseverance, you could go and collect those backup samples. So theoretically, again, the Chinese mission could land right where the sample is that was dropped on the surface of Mars and pick it up, and then that's what it brings home. Could it do that? Again, theoretically, yes. But you've got to land exactly on top of the sample, which is going to cause damage to the sample with your exhaust plume. So you got to land near the sample, then you got to send a rover, which, maybe the Chinese Mars sample return mission is going to have a helicopter, but we're still not entirely sure exactly what's going to be on board. And then, does it create an international incident? I don't think so. I think that scientists in general would like to get their hands on samples of Mars, and especially the most interesting rock that's ever been found on Mars. They would like to have that brought back. And I think American scientists, European scientists, the people who helped contribute to the funding of Perseverance, ideally would like to have those samples in the hands first of American researchers and then share that knowledge with around the world, which is generally U.S. research is more public, more transparent than the research that comes out of China. But China is sharing their information with the public. They are sharing their lunar samples with other nations, and they are sharing and publishing a lot of papers on the work that they're doing. So it's not like it's this completely closed scientific community and you only hear what they want you to hear. It's a more permeable boundary where some things it is kept very close to the chest, like, especially when it has military implications, but other cases, there's a lot of collaboration that goes on. The FAST telescope, which is, 500 meter telescope in China, a lot of foreign researchers go and do work on this telescope and get their information out. There's a lot of interesting collaborations between China and other nations. There's a telescope, the Einstein probe, which is a collaboration between Europe and China. And so they could have various collaborations baked in to determining some of this research. And from the lunar samples that the Chinese have already brought back, they have shared a lot of samples with other nations, other scientists, that people can study this independently. So my guess is it'll be a blend of that. Like, it's a huge bragging rights to say we brought samples of Mars back. We brought that specific rock back to Earth so that people can study. And you don't own that rock. Nobody owns that rock, right? That anyone is free. If you can get there and you can dig a little chunk out of it and bring it home, then that's fair. Right. So I think it would be, I think for the US, they would feel, a little frustrated because they had found the rock and would love to get the samples. But at the same time, they're canceling the sample return mission. And so I think in general, if you asked most US planetary scientists, would it be all right with you if China went and grabbed that rock and brought it home? They'd be like, yes, that would be fine with me. And I hope they share.
Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. In this week's bonus question, what's going on with Vera Rubin's data? I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank you, everyone who asked your questions in the YouTube comments, everybody who joined me for the live show. Now, we didn't do a live show this week. I'm not sure if we're going to do one next week. We're still trying to sort of sort out my internet, and we've got a lot of temples to go and see. So, but we've got a lot of backlog questions that we're packaging up, and that's what you're watching. Now, I'm going to sort of follow up on last week's rant, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Braley Roofing, Brian Bodie, Carolyn, Chuck Hoggins, Commander Baylock, Cy Nielsen, Dark Finga, Dave Verioff, David Giltonen, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Berg, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Robach, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fallon-Munley, Team 49, Telescopes Canada, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So last week, someone asked a question about, why I always say that I'm a journalist and I don't have an opinion. And it was interesting. Like, it really set off quite a response in the comments. Now, mostly it was really good. There was a few people who sort of questioned my perspective on trusting the scientific consensus. And so I want to just emphasize that this week, which is that if there is a question where the answer requires expertise, then the person who is best qualified to answer that question is the person who has studied it for as long as possible. The more years, the better. And we've gotten to this really strange place in our modern society where a person with expertise, a person who has dedicated their life to studying a subject, is seen to be less reliable, less trustworthy than a person who just is making stuff up. And that is bonkers to me. Now, scientists are just people. And so obviously you're going to have situations where someone's going to have theories that are out there and are unsubstantiated, and they're pushing a narrative and all kinds of stuff. But the scientific consensus is designed to deal with that, where you have hundreds, if not thousands of scientists who are scrutinizing each other's work in this kind of Thunderdome cage match of science. And if anyone has put their neck out too far, then they're going to get it cut off by other scientists who are reanalyzing their data, questioning their hypotheses, questioning their outcomes, checking to see if they're studying their data incorrectly. Like, it goes on and on and on. And the more people you have involved in this process, this very transparent process, the better things go. And so, there's going to be a bunch of you watching this, and you're like, yeah, Fraser, I get that for this and that and this other thing over here. But for this thing that I really care about, that is kind of charged politically, that's not true. That you can't trust the experts, you can't trust the scientists, that people are, and I want to propose to you that you're wrong. That, in fact, there is a larger culture war that is going on. There are people with money who are attempting to discredit the whole role of expertise in our modern society because it benefits them. And when you look at things like people attacking Wikipedia, or people attacking climate change researchers, or people attacking infectious disease scientists, that there is a larger agenda to do that. And so, who are the people who have an alternative agenda? Is it the scientists who really don't make very much money? Or is it the oil manufacturers? Is it the automotive companies, right? Like, there is billions of dollars to be made if people will distrust experts. So I know I'm not going to convince you, but I want to at least have you just question, just like in your mind go, is somebody trying to make me not trust experts? And what do they get out of it? So just think about that. All right, we'll see you next time.